Welcome back everyone. In this lesson, we are going to be looking at setting up our farmland. So to begin, we are going to create a brand new node. Now this is just going to be one of the white nodes, okay, the base node in Godot, and I'm going to call this one Farm Manager. This is going to be an object that basically controls the state of our farm. It is going to keep track of all of the crops. It's going to run the code required for when we want to plant, when we want to water, when we want to till, when we want to harvest. It's going to really be the core of our farm here. Now, as a child of the farm manager, I'm going to add in a brand new tile map layer node, and I'm just going to rename this to be tile, or we'll call this one farm tile map. Now, inside of this is where we're going to paint in our grass tiles, which can then be interacted with by the player. So over in the inspector, we're going to go to where we have tile set and add a new tile set right here. Now, we need to give it a tile source. So I'm going to go over to my tiles inside of my sprites folder and drag in the tile set PNG. I'll say yes. And if we zoom in, we should see that our tiles here are cut up. But there is kind of a bit of a weird thing going on where it is not including the space here. So I'm going to go over to separation and just set this to be 1. Now our tile should be nicely cut up. What I'm then going to do is go over to our tile map window down here, select the grass, and then we can begin painting them in. I'm going to select the box tool and just select a very large area, okay, like that. Now, you may notice that our player is missing, and that is because the player is actually beneath the tile set, okay? Just based on the scene hierarchy here, the tile map gets rendered, then the player, but there are some issues with, if they're on the same plane, there can be some issues with that. So I'm going to select my tile map here, go to the inspector, go down to ordering, and change the Z index to be something like -100. So it is always going to appear behind. Now, if I press play, you can see we have our farmland and our player can walk around it. So we have that all set up. Now in the next lesson, we are going to begin creating the code required for our farming game to work, starting by setting up our crop resources, which represent a crop, its growth stage, its sell price, etc. So thanks for watching, and I'll see you all then. Welcome back everyone. So in a farming game, you typically have different types of crops, and we will be supporting essentially an unlimited amount. You can add as many different types as you want, and they should all be able to work nicely. So the way we are going to be doing this is each crop type is going to have its own data file, which is going to be stored in our file system. And that data file is going to keep track of stuff such as its sell price, its seed price, how many days it takes to grow, and the different sprites showing the growth progress. So what we're going to do is create a custom resource, and a resource essentially in Godot is anything you see here in the file system. An audio file is a resource, a scene file is a resource, a script or a sprite. Those are all resources, okay? Essentially data we are saving to our project files that can then be loaded in, used, and read. So what we're going to do is go to our scripts file, scripts folder and create a brand new script here. And I'm going to call this one crop data, okay? Just like that. Now let's open it up. And inside of crop data, what we're going to do is first of all go to where it says extends node and replace node with resource. Now this is no longer going to be a script that we can attach on a node inside of our game. Rather, this script is going to represent a piece of data in our file system. Now we need to give that data a name, so I'm going to go class name and call it crop data, like so. Then we can give it some variables. So I'm going to create an export variable here for the growth sprites, which is essentially going to be an array of textures. And this is essentially going to show how it grows from a seed up to a complete plant. If we go over to our sprites folder, down to where we have crops, you'll see we have for corn and tomato growth progress for each. So corn, we have growth 0, 1, 2, 3, 4, tomato 0, 1, 2, 3, 4. Okay, and we can see how each of those change. So for the tomato, you can see how the tomato plant grows over time. Then we need an export variable for the days to grow. So how many days is this crop going to take to grow? I'll make it 8 by default. We then want to export variable for our seed price of type int. So how much does it cost to purchase a seed of this crop? We'll make that 10. And then export variable, what is the sell price? So once we harvest the crop, how much are we going to sell it for? And I'll just say 20 for default here. Now, if you remember, we went ahead and created a crops folder already. And inside of here is where we're going to store those. So I'm going to right click on crops, go create new resource, and then if I search for crop data, you should see it pop up right here. Okay, I'm going to click create. I am going to call this one tomato. And inside of crops, you now see we have a tomato.tres file. If I double click on that, you'll see in the inspector, we can assign those properties. So days to grow, seed price, sell price, and growth sprites. So for growth sprites, I am going to set the length of this to be the length of tomato growth sprites here, which is 5. So I'm going to set that length to be 5, and then drag in 0 into the seed. 1, 2, 3, and 4. Now, when our crop is actually growing in game, we can check to see our progress and assign it a sprite. Okay, so if we have just planted it, it'll be a seed. If it is around halfway, it'll be this sort of semi-grown plant. And then finally, when it is fully grown and ready to harvest, it will be this big tomato plant here at the bottom. Let's do the same thing for corn. So I'm going to create a new resource, crop data. I'm going to call this one corn. And inside of here, again, we want to set our growth sprites to be a length of 5, as that is how many corn growth sprites we have. Drag those in. And feel free to add more as well. If you want other plants as well that you can grow, other crops, feel free to add those in, as more the merrier. So there we go. We now have our crop data for our corn and for our tomato. Now, these are going to be very important because in order to actually determine which crop we want to grow, we need to have a crop data. So this is really the core of our farming system, okay, the crops. Now, in the next lesson, we are going to be creating a script that represents not the crop data, but the crop itself inside of the game. Now, this crop script is going to basically keep track of how many days it's been around for. It's going to keep track of whether or not it's watered, whether or not it can be harvested, and that is then going to allow us to create our farm manager, which can then plant the crops and have the entire system working. So thanks for watching, and I'll see you all then. Welcome back, everyone. In this lesson, we are going to be creating our crop script. Now, the crop script is essentially going to be attached to a crop when it gets planted. So you can think the player, they're walking around, they plant a crop, that is going to instantiate a new crop scene. And inside of that crop scene, we're essentially just going to have a script which detects how many days have passed, and each new day it is going to update that sprite depending on if it's watered or not. So what I'm going to do is I am going to go ahead and create a brand new node 2D right here. Node 2D, and I'm going to call this one crop. Now, it's going to be pretty bare bones. We're not really going to have much going on here, and that is because, again, a lot of this is going to happen in script. So we are only going to have one child node of crop, and that is going to be sprite, which I'm just going to call sprite right here. And we're not going to assign anything because that is going to be assigned, like I said, in code. Next, what we're going to do is attach a script to the crop, and this script is going to be, of course, you can probably guess, yep, it is going to be called crop. So we're going to open that up, click create, and here we are. Now, inside of this crop script, what we're going to do is we are going to give it a class name of crop. And since this crop script is not dependent on any specific crop type, we then need to know which crop it is, okay? Is it a tomato or is it a corn crop? Well, we're going to have a variable called crop data of type crop data, and this is how we're going to know if this is a tomato or if this is a corn crop. We then also need a variable for days until grown. So when we plant this, it is going to be set to something such as 8, and each day that progresses, it is going to be subtracted by 1 until it reaches 0. And when it reaches 0, then hey, we're good to harvest it. We also need a variable for watered, which is of type bool, so has this crop been watered or not, and another boolean variable for harvestable, harvestable, and this is going to basically be true or false for whether or not the player can harvest this crop. Now another variable we're going to have is going to be called TileMapQuards, and this is going to be of type vector2i, and this is essentially going to be the position of this crop on the tile map. Okay, it's going to pinpoint to a specific tile that this crop is on. Now, what is vector2i? Well, vector2i is essentially a vector2 that uses integers, okay? And the reason why we're doing this is because the typical vector2 uses floating point numbers, which for directions and positions can be good, but if we want to have a specific tile map coordinate, which is dealing with hard values, we don't want it to have any floating point rounding errors, okay? We want it to be very exact. And then finally, we're going to have another variable, which is going to be our sprite, and we can assign that just by dragging it in like so. Okay. Now we're going to be setting up our functions, but not necessarily filling them in just yet, because we do need a couple more things set up first. So I'm going to create a function here called ready, and this is of course just the ready function. We're then going to have a set crop function, which is going to take in 3 parameters. It's going to take in the crop data. It's going to take in a boolean for already watered, because if we are planting a crop on a piece of ground that has already been watered, we want that information to be passed over when we plant the seed. So that's going to be transferred over this way. And then we want the tile quads, okay, which is going to be of type vector2i. Let's just set these values while we're here. So we're going to go crop data equals data. We'll go watered equals already watered, and then we'll go tile map quads equals tile quads, and let's then also set harvestable equal to false, because when we plant a crop, we don't want to be able to harvest it. Also, while we're here inside the set crop function, we're going to set our days until grown to be equal to the crop's data dot days to grow. Remember, in the crop data script, we have this days to grow variable. We're essentially just setting that here. And also, let's set our initial sprite. So here we'll go sprite dot texture equals crop data dot growth sprites. Now, inside of the growth sprite, so for example in corn, we want its first sprite to be the seed. So we need to get the element 0. So here we'll go growth sprites in square brackets 0. So it's getting essentially the seed for this crop. Now we're going to have another function, and this function is going to be called on new day, and it's going to be sending over a day parameter. Now this function is actually going to be connected to a signal that we'll be setting up later inside of our game manager script. We're going to have a centralized location, a centralized autoload script that is going to manage a bunch of different signals that anything can just connect to or emit. Okay, and for now I think we'll just pass on this one, as we don't necessarily need to set it up just yet. So that right there is our crop script inside of our crop object. Let's just go ahead, set its position to be 0, and then we'll save this as a scene, okay? Just like that. Now, what we're doing right now, it may be a bit hard to understand because there's no real visual element, there's no real growing of the crops or placing of them just yet, but this is the foundational stuff we need in order to actually build out our farming system, okay? But don't worry, in the next lesson, we are going to begin creating our farm manager, which is going to look at having the player change the state of our cropped land here, so we can change it to tilled, then watered, then we can plant a crop on top. Okay, so let's delete this crop here. Thanks for watching, and I'll see you all then. Hey everyone, in this lesson we are going to be creating our farm manager script. This is going to be a script which basically runs our farm. It's going to keep track of where all of our crops are, as well as the state of each of our tiles. Is it grass? Is it tilled? Is it watered? And then upon each new day, it's going to basically update all of those things. So let's go ahead and create this script. I'm going to create it over on my farm manager node right here, which has the farm tile map as a child. And I'm going to go ahead and create a new script here. Make sure I'm saving it to the right folder, and I'm just going to call it Farm Manager. Now, first things first, we need to give our Farm Manager a class name, just so it can be easily referenced elsewhere. So class name Farm Manager. Then what we're going to do is we are going to be creating some, not variables, but some little extra bits that we are going to be needing. The first thing we're going to need is something known as an enumerator. Now, an enumerator is essentially a custom data type that we can create with predefined values. Think of it sort of like a drop-down menu in Excel. Okay, so I'm going to go ahead and create my enumerator here by typing enum. Then I can give it a name, tile type, and have these opening and closing squiggly brackets where we'll then enter in our different enumerator values. Now I am going to have grass. We can then go comma, new line, tilde, comma, new line, and tilde underscore watered. Now, what are we doing with this? Well, essentially, tile type is going to be used whenever we want to, for example, change the type of tile that we have on our tile map. Because if I select our tile map, you'll see we have four, well, technically four, okay? The fence isn't going to really be something we can plant or post or something like that. But you can see we have our grass, our tilled grass, and then our watered tilled grass. So essentially, whenever we say, for example, we want XYZ tile to be tilled, we will go tile type dot tilde. That is how we are going to refer to these three different tile types. Now, something else we will then also need is going to be a class called tile info. I'll write that out right now. So class tile info. I'm then going to add in a colon and go to a new line. And in here, I'm going to create three variables. One called tilde of type bool, one called watered of type bool, and then one called crop of type crop. Now, what are we doing here? What is this class tile info? Well, essentially what we're doing is creating a new class. And a class is, you can think of it like a script, okay? For example, our player script right here, this is technically a class, okay? It has variables and it has functions. Now, a class, one class is sort of distinct from another based on the fact of it does a certain thing. For example, our player script here animates and moves our player around. Okay, you can think of the player class would then move the player around, animate them, as well as having its distinct variables. Our crop class over here, that is why we are defining the class name. We're giving this script, the class, a name. Okay, the crop class has all of the data and the functions required for this crop to grow. Likewise, inside of Farm Manager, it itself is a class called Farm Manager. Now, what we are doing down here is creating our own a little extra class on top of that, okay, that we are going to be using. And we can then instance this class into objects. So for example, each tile in our grid here that we till and use is going to be represented by this tile info. And this is essentially how we save and create the tile state. Is it tilled? Is it watered? Does it have a crop on it? And if so, what is that crop? We'll get into this more, of course, when we start implementing it. So let's continue on with some variables. First of all, we need an onReady variable for our tile map. This is going to be of type tile map layer, and this is just going to be equal to our farm tile map right here. We then need to create a list of all of the different tile infos, because if we begin farming, and let's just say this tile right here, we want to till it. Well, we need to keep that state information, as well as when we eventually water and put a crop on it, we need to know exactly what crop is assigned to which tile and all of that info for this singular tile. Now, we are going to store this in what is known as a dictionary. So I'll write tile info of type dictionary. And then in the opening and closing brackets, I'm going to write vector2i, comma, tile info. Now, a dictionary is very similar to an array, okay? An array being a variable which can hold multiple values. A dictionary does the exact same thing, but instead of accessing each element with a integer index number, we access each element with a specific key that we can predefine. Now, our key is going to be of type vector2i, okay? An integer vector2. So for example, if we have tile, let's just say 2, which might be this one up here, that is then going to be used as the key to return to us its specific tile info. Okay, so this is just sort of like a bit of a database, you can think. Now we also need our crop scene, and this is going to be so that we can spawn it in. So packed scene equals preload, and we then want to go down to crop, where is it? Scenes crop, there we go. And then finally, we are going to create another dictionary, but this time it is going to basically just store all of our different possible tiles, okay? And I'll show you what it is. We're going to write it out first. It's going to look a bit strange, but I'll go over how it works. So I'm going to create a variable called tile atlas chords of type dictionary. The key is going to be the tile type enumerator right here, so it can be grass tiled or tiled watered, and the data or the value is going to be a vector to I. Now we are actually going to predefine the values for this dictionary, so I'm going to go equals, have an opening and closing squiggly bracket here, and inside of this dictionary we can basically predefine its elements as you would with an array. So first of all, we define the key, so tile type dot grass, and this is then going to go colon, we can then give it a value, vector to I, 0, 0, then go comma. Our second element is going to be tile type dot tilde. This is going to be with a value of vector to I, 1, 0. And then finally, we have tile type dot tilde watered, okay, with the value of vector to I, 0, 1. Okay, now what are we doing here? This looks kind of confusing, but let me go over it. So whenever we, for example, till or water the ground, we want to change this specific tile's sprite. But how do we do that? How do we know what sprite to actually use? Well, for example, if we till the ground, we're essentially going to tell the tile map to change that sprite to be the tile type dot tilde, but this is an enumerator and we can't really link this to our tile map directly. So what we need to do is use this dictionary as a proxy. We can give it, for example, a tile type, grass tilde or tilde watered, and it is going to return to us a vector to I position. Now this position is going to be relative to the tile set, okay, the tile set, which is an atlas, and an atlas is essentially just a collection of different textures. Now you can see here, when I click on a tile, you'll see at the top right we have these two numbers, an X and a Y. And these are what are known as the atlas coordinates, okay? You can see if I click on the tilde one, that changes to 1, 0. The tilde watered, 0, 1. This is essentially the position or the index of this tile on the tile atlas. So if inside of our script here, we are basically assigning the tile type grass to be this specific vector to 0, 0, that is the grass tile. Tilde, that's 1, 0, so 1, 0, as you can see here. So now what we can do is whenever we want to change our tile map tile, we just need to give it the tile atlas coordinates, okay? And it is going to know exactly what tile to replace it with, okay? So there we go. That is our variables listed out. And in the next lesson, we are going to begin listing out all of the different functions that this script is going to have. Thanks for watching, and I'll see you all then. Welcome back, everyone. In this lesson, we are going to be listing out the functions that we are going to be writing for the farm manager script. We're not going to be filling them in just yet, just laying out the framework so we know exactly what we need to do. So, first of all, let's create the ready function, which of course gets called when the node is first initialized. Here is where we are going to essentially connect to signals and set up our tile info dictionary, okay? The next function we are going to create is going to be on new day. So on new day, which is going to have a day integer parameter. Now this, you may notice, is very similar to our crops on new day function, and that is because this on new day is going to connect to a signal that we are going to create in the future, okay, which is going to then emit upon each new day. And here essentially is where we are just going to update the tile state to basically show when the new day occurs. Because remember, if we are tilling a piece of ground and there's no crop on it, it is going to disappear the next day. Then what we need is another function which is going to be connecting to a signal called onHarvestCrop. This is going to send over a crop parameter. And this is of course going to be called whenever the player harvests a crop. And inside this function, we are essentially just going to update the tile info and update the tile sprite to show that there is no longer a crop on there. Okay, the next function is going to be called try_till_tile. Now try_till_tile is going to be sending over a player position. Okay, so player pos of type vector2. And this here is going to be called whenever the player has their hill or their hoe selected and they interact with the ground. It essentially just going to send over the player position, and this function is then going to figure out what tile the player is standing on and attempt to till it, updating the tile info, etc. Now, likewise, we also have all of our other tools. For example, we have the function, and we can actually just copy and paste this one over. So we have the function try water tile. So this is when the player has their water bucket equipped and they're trying to water the tile. And we then have try seed tile. And this is going to be called when the player tries to plant a seed. But when they're planting a seed, we don't just want to know their player position, we also want to know what seed they are trying to plant. So we are going to have another parameter called crop data of type crop data. Okay. Next, we are going to have the try harvest function. Now, try harvest is going to be called when the player has their scythe equipped and they are trying to harvest a fully grown crop. Of course, if the crop is not fully grown, it is not going to harvest. And then this is going to go through the process of giving the player money, etc. Okay, the next function is going to be called isTileWatered, and this is going to take in a position. So we'll just go pos of type vector2. And this is going to return a true or false value. So we'll write bool right here, and we'll just go return false by default. And this is going to be needed for when we want to know if a certain tile at this position has been watered or not, of course. Okay. And then finally, we have the set tile state function, which is going to take in a tile coords vector to I. So this is going to be the coordinates of a tile relative to the tile map. And we're then going to have a tile type. Okay, so tile type. And essentially this function is just going to, for example, if the coords are, for example, like 3, 6, which might be this tile right here, and we send over tile type.tilde, it is just going to turn this tile into a tilde tile. That is how we are then going to set these things. So these are all the functions that we have for this script. Okay, this is probably going to be the biggest script of our game, probably around 130 lines long, but we're going to go through and understand everything as we go function by function, line by line. Now let's start inside of the ready function here. Now inside the ready function, we're going to do two things. We're going to connect to signals, so we can add a little comment here, go connect to signals. We'll go like remember connect to signals, just so we don't forget later on once we implement those. And then what we need to do is set up our, our tile info dictionary, okay, for each tile in our tile map. So each tile here is going to have its own element inside of this dictionary here. Remember, the vector2i is the position of the tile, and the tile info is a custom object which contains the info for that tile. Is it tilled? Has it been watered? And is there a crop on there? So what we're going to do here inside of ready is loop through every tile inside of our tile map. Now to do that, we're simply going to go for cell in tilemap dot get used cells. Get used cells essentially means all of the tiles that have an actual tile on it. So for example, these tiles out here that have nothing on it, those won't be included in that for loop, only the ones with an actual tile. And with tile maps, the term tile and cell are pretty much used interchangeably, okay? Each of these squares is a cell, which is a tile. Now, for each of those tiles, we want to essentially add it to our dictionary. So for this, we are going to go tile info in square brackets, give it the key, which is going to be our cell position, because cell right here is a vector2i, and that is going to equal tileinfo.new. Now, the .new function right here basically just gets this class and creates a new object out of it. So we have a new instance of tile info. And that is how we can initialize every single tile in our game into the dictionary here. Now we can change the state whenever we wish. Okay, and next I'm going to go down to where we have set tile state. Now, set tile state, here essentially what we're doing is we're sending over a tile coordinate and a tile type. So for example, like I mentioned before, if we send over this tile's coordinate and we set the tile type here to be tilde watered, we are going to change its sprite to be tilde watered as well as the tile info state. So inside of this function, we are first of all going to set that cell's sprite. We can do this by going TileMap.setCell. We need to give it the coords. We then need to give it a source ID, which is just going to be 0, so the first tile set, and then an atlas coords, which is going to be the tile atlas coords, and sending over the tile type, and that is going to fetch the correct sprite. Then we need to go through each of the tile types and check to see if it is equal to this one. Now we could use an if statement, but I'm going to use what is known as a match or a switch statement. So I'm going to go match and then go tile type. Then on a new line, we can go tile type.grass. And then in here, we can simply go tile info coords dot tilde equals false. And then tile info coords dot watered equals false, because if we are setting it to grass, then this is no longer a tilde tile, and of course it cannot be watered. We can then go tile type dot tilde. Now if the tile is tilde, let's just copy and paste these over, then that means tilde is equal to true, but watered is still equal to false. And then finally, if the tile type is tilde watered, then that means it is both tilde, so we can set that to be true, and it is also watered. Okay, so this is how we can change the actual tile state pretty easily here. Now, the rest of the functions, such as trying to till, trying to water, is going to require the player's tool system. So in the next lesson, we are going to jump over and begin setting up our player tools so they can start interacting with the tiles. Thanks for watching, and I'll see you all then. Welcome back everyone. In this lesson, we are going to be setting up our player tools. Now, a player tool is going to be one of four things. It's going to be the hoe to till the ground. It's going to be the water bucket to water the ground. It's going to be the scythe to harvest the grown crops, or it is going to be a seed which the player can then plant in tilled ground. Now, the player tools are not going to be run on the player script. We're going to create our own script for that. So, as a child of player, I'm going to create a new node. This is just going to be a node 2D called player tools. In fact, we can just call it tools. Then we're going to attach a script to this one. And this script here is going to be called player tools. Just like that. Okay, so inside of player tools, let's start by giving it a unique class name called player tools. And then we are going to create an enumerator just as we done in our farm manager, but for each possible tool. So here we're going to go enum tool, and we are going to have a hoe, we're going to have a water bucket, we're going to have a scythe, and we're going to have a seed. So these are the four different possible tools the player can equip. Now we need a variable to keep track of the player's current tool. So current tool, this is going to be of type tool, of the enum we just created there. And also, if the player is equipping a seed, we need to know what seed they are equipping. So we're going to have another variable called current seed of type crop data. Then we need a reference to our farm manager because all the functions we want to call are over on there. So on ready var farm manager of type farm manager equals, we can then just drag in our farm manager to get a reference to that. And then we can create our functions. So our first function is going to be ready. Now inside of ready, we aren't actually going to fill anything in here just because we need to basically, this is where we will be connecting and emitting some signals. So here we'll go, remember, connect signals. There we go. And then the function that is going to be connected to the signal is going to be called setTool. Okay, and this is going to have two parameters, a tool of type tool and a seed of type crop data. Now, this function is going to be called when the player clicks on one of their UI buttons. So if they click on the button with the scythe, this function is going to be called with tool.scythe being sent over and seed as null. But if they click on a tomato seed, for example, tool will be seed, and the seed here will be the tomato crop data. So inside of setTool, we're simply going to go current tool equals tool, and current seed equals seed. Now, this is how we can change our players' tools, but what about actually using them? So here I'm going to create the process function, and inside the process function, if we go up to project settings, input map, you'll see here we have the interact key that we already defined. So if we then go if input.is action just pressed, and we go interact, then what we can do is basically on our farm manager call either try till, try water, try seed, or try harvest, depending on the player's tool. Now, how do you think we're going to do that? I'll give you a hint. We've already done it previously in the farm manager script. And yep, that is going to be using a match or a switch statement. So here we are going to go match, and that's going to be current tool. So we're basically going to check through current tool, and depending on its value, we will do different things. So for example, if that is tool.ho, then we are going to go farm manager dot try till tile, sending over our player's global position. Okay, just like that. Likewise, if the tool is the water bucket, then we'll go farm manager dot try water tile, sending over the player's global position. And then likewise, we can do the exact same thing for the scythe and for the seed. Okay, so if it's the scythe, we're going to try harvest the tile, and if it is seed, we're going to call try seed tile, sending over the player's position as well as our current seed. Okay, so that is how we're going to set all of that up. Okay, and that is our player tools function set up and ready to go. Now what we need to do is, before we actually connect the signals to set the player tool, let's just go ahead and set the default tool. So we'll just go current tool equals tool.ho. Okay, so we can basically till the ground. Now, if I run this, you'll see that I can walk around, and then if I press F or E, well, nothing really happens. Okay, we don't really see anything changing, because even though the try till tile function is being called, let's go over to farm manager, try till tile, we'll print out till just to see if it works. Okay, there we go. We have till being printed to the output. Nothing is happening, and that is because we, of course, need to go ahead and set up the functions over in the farm manager, and that is what we're going to do. We're going to be making it so that each of these try functions are actually going to begin implementing their functionality. So thanks for watching, and I'll see you all then in the next lesson.